Okay, we're out at our horticultural research farm here in Lexington, and we're going to talk about fruit nutrition, specifically about calcium nutrition, nitrogen nutrition, and iron nutrition. Soil pH is very important in determining nutrient availability, and if your pH is too high or it's too low, certain elements are not available. We've got a chart here that shows nutrient availability on a pH scale. A pH 7 is neutral, and so for our fruit crops we like a pH of 6.5 for most of our fruit crops. You can see that iron here is very available at a low pH, and as the pH gets higher it's less available. What this means is that iron is tied up in the soil. The plants can't pull it out of there. You can see here that nitrogen is not available at a low pH and not available at a high pH, and you can see the calcium availability is pretty low at a low pH. So this is our matted row planting. This is the third year of this planting, and we've harvested it for 2 seasons. We're about ready to take it out. We've got some leaf disease here, but what we noticed last year was some of the leaves were looking a little deficient, and this one right here, we thought last year we had an iron deficiency. So we ran a soil pH on this plot, and it turns out our soil pH was 7.4, unbeknownst to us. So we were sort of surprised. Most of our plots don't have that high a pH here out at the farm. And so what we decided to do was put some sulfur on to lower the pH and make the iron more available. Now, at renovation, we come in and mow the plants off to get rid of any of this leaf disease, and then we applied the sulfur over top. We broadcast it over the whole planting, and then we came in and cultivated with a rotavator and narrowed our rows to get rid of some of the older plants and cultivated that sulfur in. Sulfur goes into the soil very slowly, and you can see we didn't get the response that we wanted. It didn't get cultivated in down the row, and we're still seeing an iron deficiency. This is Chandler, and this variety seems to be particularly sensitive to an iron deficiency. In our plant disease diagnostic lab, we've had a number of samples sent in over the years with iron deficiency, primarily with plastic culture strawberries, where they're using calcium nitrate as a fertility source, and it raises that pH up in the root zone just beneath the plant. A better choice would have been to apply a foliar iron chelate, which would give short-term results, and a little longer-term solution would be to apply a slow-release fertilizer, such as this Osmocote Plus 15-9-12 plus minors, which is a 3 to 4 month release. Or you could put on Scott's Top Dress Special 17-3-6 plus micronutrients. These are a prill. This is a pretty expensive fix. You just sprinkle it on the plants, and the rain will take the nutrients into the soil. Now these supply nitrogen, phosphorus, and potassium, and a lot of micronutrients. What we're interested in here is the iron. The iron is in a chelated form, which means that that iron molecule is inside this chelate, and the plant can pick that molecule up when the soil pH is pretty high, strip the chelate off, and get the iron out. So this is a solution where you have too high a soil pH. But this is a band-aid approach. The long-term solution is to lower the soil pH. Let's go take a look at. We're in our new blueberry planting, and iron is a real serious problem in blueberries. Blueberries require a low soil pH because they are not able to pick up iron at high pHs, and the roots don't have root hairs, so it's difficult for them to pick up iron. So we've got to get that pH for blueberries down to between 4.5 and 5. And that's extremely important when you're planting a blueberry planting. You've got to get that done the year ahead of time. Here's a typical shoot on a blueberry with a nice color on the leaves, good leaf size. This is what you're looking for. Here is a blueberry plant showing iron deficiency. You can see the dark green veins on the leaves and the light yellow color in between the veins. This is showing up on the youngest leaves. Iron is not mobile, so any iron in the plant is locked up in the lower leaves, and the plant is not moving the iron to the youngest leaves. So that's why the deficiency shows up in the youngest leaves. Here's an extremely iron deficient plant on a blueberry, and you can see the leaves are almost a bright yellow with, again, dark green veins. So to get the soil pH down on blueberries, the cheapest way to do it is to apply sulfur to the soil. And again, you need to do this a year ahead of time because it takes a long time for that sulfur to lower the pH. Now, a clay soil requires a lot more sulfur than a light sandy soil, so you need to get a soil pH measurement and do those adjustments a year ahead of time. A lot of our growers get antsy and put their blueberry plants in too early before they get that soil pH adjusted, and it's very difficult to adjust that soil pH once you have those plants in the ground. The reason being is that sulfur, if you put too much sulfur on the soil bacteria are responsible for eating that sulfur and converting it to sulfuric acid, which lowers the pH. If you put too much sulfur in around a plant, you'll burn the roots and fry it and kill it. So once you have the plants in the ground, you can only put on about 0.9 pounds of sulfur per 100 square feet on the planting without burning the plant. So it takes a long time to get that pH down. The option is to apply chelated material like this Osmocote or the Scott's Top Dress Special. If we put on about 2 ounces of this per plant, sprinkled around the base of the plant, in situations where we've got a serious iron deficiency, you put it on in March, April, May, June, and July. Now you say, well, this is a slow release fertilizer. It's supposed to release over a 6-month period. Why do I have to put it on so frequently? Under our high temperatures, most of that iron dumps out in about a month. So putting it on a monthly basis. Some of our bigger commercial growers make an application or 2 of this during the season. Just to keep their plants looking good. This releases a lot of other micronutrients as well as supply nitrogen. Blueberries like a long, slow nitrogen release. Now this is not an organic material, so if you're doing things organically, sulfur is your main way for lowering the soil pH. Another means of lowering the soil pH is aluminum sulfate, but we can get into aluminum toxicity problems, and it takes 4 times as much aluminum sulfate as it does sulfur to lower the pH, so we tend to stay away from aluminum sulfate. In this planting, we developed our rows, laid them out, put down composted pine bark, and then we came in with our bed shaper and threw up some beds that incorporated that composted pine bark in the beds. Then we came in and dug our holes and put about 1 gallon of moist peat moss in the bottom of the hole, mixed it in with the soil, and planted our blueberry plant. It's very important to mix that peat in with the soil to keep it moist. If you plant the plant directly into peat, sometimes that peat will get dry, and when you try to irrigate it, that peat will shed the water off and you'll have a stressed plant. After throwing the beds up, we put bark chips on here. This is hardwood chips. This is what we had. Ideally, what we like to put down are pine bark or pine sawdust or pine needles. They make a much better mulch because as this hardwood mulch breaks down, it releases calcium, so it raises your soil pH, and you're trying to fight to keep that soil pH down in most cases. So those are some of our options. We put 2 drip lines on top of here. These have emitters inserted into them, so we don't have emitters popping out. There's an emitter every 2 feet, so we've got an emitter close to each plant, and this puts water on both sides of the bed. We're trying a new system out here, one that they're using in Oregon, using a zippered landscape fabric system. You can see it over here, and this is split in the middle, and it's staked or pinned down in the middle. This way we can come back after several years and open this up and reapply mulch underneath of it. Mulch is important for blueberries. Not only does it break down and release nitrogen over a long period of time, but it moderates the soil. This plant has a severe nitrogen deficiency. You'll notice that the leaves are smaller in size, they're yellow pretty uniformly throughout the plant, and we've got some red coloration on the the younger leaves. When we compare that to a blueberry with excellent nutrition, you can see we've got real spindly growth here. When we have a good nitrogen level, we get a nice caliper of growth, and we have nice dark green leaves. So how do we combat nitrogen deficiency in blueberries? Nitrogen leaches through the soil profile with the rain, so we put nitrogen on every year, and nitrogen determines how much growth you're going to get on the plants. With blueberries, we want to put nitrogen on at bloom and then 6 weeks later. With this system, we're going to fertigate it on and put a nice light application on throughout a good portion of the season. So typically in a conventional planting like this guard row right here, we would put 0.1 pounds of ammonium sulfate on for the first year at bloom and 6 weeks later, and we will sprinkle it around the plant so that we get good uptake. With blueberries, the leaves on this side are not hooked to the roots on this side, so we need to put it in a circle around the plant. The ammonium sulfate will leach in with the rainfall and do a great job. The second year we'll put 0.2 pounds on at bloom and 6 weeks later, and then the third year and thereafter we'll put 0.3 pounds on at bloom and thereafter. Blueberries do not like nitrogen in the nitrate form or the NO3 form. Ammonium sulfate has nitrate in the ammonium or NH4 form. If you put too much calcium nitrate on a blueberry plant, it's very easy to kill it. They don't like that nitrogen in the nitrate form. So we've run into some problems on these plants because we didn't get our fertigation set up, so we decided to put it on manually, and we mixed up 0.1 pounds of ammonium sulfate in a pint of water and poured it on our plants. And that was a big mistake. Typically when we put ammonium sulfate on the plants, it goes on the surface of the soil and then it leaches in with the rainfall. We gave these plants a really heavy shot right in the small root system because these were just recently planted, and we burned the roots on a lot of these. Let's take a look at one of these plants over here. Here's a plant that completely defoliated because of too much salt around the root system. So we're probably gonna lose this plant and have to replant it, or maybe it'll come back after a little bit. We'll just have to wait and see. Yeah. As an aside, this is another situation that we ran into that we weren't expecting. I figured these blueberry stems were pretty tough, but where they touched this landscape fabric, they burned the stem and girdled the stem. So these plants are going to have to come back from their roots where they were burned. So we've made some mistakes. We learned by our mistakes. Hopefully you'll learn from some of our mistakes.